Hi everyone, I'm Ash. I'm GD for Kotlin and Android in Berlin, Germany. I'm here today to talk about navigation with Multiplatform. But to start off this wonderful annual event, I'd like to kick off with a bit of a joke. What's a pirate's favorite programming language? True, but they say that true love is the sea. And that is to obviously kick off this wonderful annual event of International Talk Like a Pirate Day. So can I get a Yara from everyone? There we go. I promise never to do that again. So navigation. It's a component that we will use in our day-to-day life and almost every aspect that we have with anything with a computer. It can be our desktops, we could be our browser, it can be our phones, it can be an automated terminal, it could be the terminal at a McDonald's. And we interact with this every day, sometimes perhaps even without noticing. But in this context, and in simple terms, navigation is the process of going from one screen to the next, usually on a mobile device. And if a term like this can be reduced so simply, then perhaps we could just use a deck to kind of handle our backstack, and the navigation is solved, job done, we can go home, right? Well, in theory we could, but in practice it's complicated. And those complications come in a lot of different form, most of them human. So you're probably all familiar with horizontal navigation. This is just going forward and backwards, navigating to a new screen, navigating backwards. But navigation is more than just a history, more than just a horizontal navigation. We've got UI concepts like the bottom rail or the side navigation drawer that introduce another additional aspect to this. So it's not just horizontal forward and backwards navigation. We've also got vertical navigation. This is the idea of going up and down in addition to left or right. And navigation, like many things, should be predictable. So user affordance is how a user expects to interact with something. Think about push-pull doors or things that you interact with on a daily schedule, daily rate, and that shouldn't need an explanation. You've got what appears to be a tap here, and it's not immediately obvious how to interact with that it requires instructions. Now, this is bad design, and it should be avoided. So we need to make sure that we behave in a predictable fashion that the user expects to handle on that device. So the behavior should be consistent with the platform expectation, whether you're working on Android, iOS, Mac, Windows, or a McDonald's kiosk. And not just each one of these different platforms, but each one of these different platforms can have different form factors, and each of these different form factors changes the way the user will expect to navigate. And even something as simple as a back navigation differs significantly. It might be a bit obvious on Android how to handle this or how it should behave. You have a swipe gesture, you have your back button, you have your up button, for example. But then desktop apps might behave differently. You might have a back button in the top left. You might have a keyboard shortcut to close this current window or to close this application. So all these different things react and behave differently, but should still follow these guidelines of affordance. What would be the expected behavior? What should a user expect to do? And as I mentioned as well, Android has both the up and back buttons, both behave slightly differently. This is a very old screenshot, it's the best I could find to demonstrate the up and back behavior. Not to mention that on Android, a configuration change, so any change to the size of the screen will cause your application to be destroyed, activity to be destroyed, sorry, and cause your configuration change. So you have to then maintain this back stack or this kind of history of navigation elements through configuration change, make sure it survives. Add on top of that, deep link behavior. So if you're linking to an app from a website, for example, you might have already experienced this where you have an app installed and then you click on a link on a website and it opens the app as though you would have navigated in that app directly. So it recreates this fictional backstack. So establishing the point that navigation is difficult, and it's often a topic of confusion, and it's something difficult to new developers or even experienced developers, and navigating from screen to screen in your app is a very fundamental process. Well, the thing is, we've already been here. This is a talk I gave in 2019 in Berlin about navigation, shortly after the Jetpack library was introduced. And that was kind of because historically, the Android framework team did not really care too much about how you structured your application. Once the activity had been started, well, you're on your own. Do what you like. But then a lot of developers were a bit unsure on how to get started, so the Android team came up with Jetpack, a set of opinionated components to sort of lead you in the right way, or at least the way that they thought was correct. The initial implementation came with some basic tools, things for type safety, safe args, but it was Android only and XML based, and we all know how much we love XML. It also introduced, or reintroduced, fragments, and fragments had been widely considered to be the worst thing ever, plagued by lifecycle issues and having a weird backstack management, but despite alternatives, usage activities remained the most popular choice. But that was 2019. A whole Billy Joel song worth of things has happened since then. But that's not to think that this was the only thing available. Back in 2014, Square came up with the idea of Mortar and Flow, which was this alternative to having activities or fragments where screens were based on a view group in a more molecular kind of structure. This was implemented with a separation of screens from presenters and view layouts handling the presentation detachment, and then Flow handled the kind of navigation with that. They continued this development into what was then called reactive workflows, but then eventually became a workflow. So this one was quite comprehensive. I'm not going to go too much into this here because it's very comprehensive. A lot of the documentations are sadly a little bit outdated. It sort of employs the unidirectional data flow paradigm and encourages a declarative syntax, and has a sort of hierarchy of parent-child workflows reacting to state change, as you'll see is quite common in modern libraries. It is, however, actively maintained, so if you have the interest, I would recommend going and check it out. It's also kind of a lot of guiding principles about the community and what we think is a good practice for development. I'll share the slides afterwards as well. All the links will be available online, don't worry. But they also said during this demonstration about workflow, what the reasons for using workflow, what would be a guide for doing this. And, you work at Square was the guidance. So maybe it's not perfect for you, but it's great for these guys and it's working for them. So it's a nice idea to kind of look at and kind of get a gauge for and just kind of get a feel for, but you don't necessarily have to kind of migrate to it. There was also Uber Ribs. So in 2016, they kind of rebuilt their entire application. Fortunately, they can do that. And they sort of did the architecture based upon this Viper approach from iOS. It's still actively maintained, mostly Kotlin with some Java tests and tutorials, but focuses on shared code between Android and iOS. But moving on, besides a few outliers, Jetpack navigation was enough for most projects, and given that it was recommended from Google, it gave a lot of people confidence in that approach. But of course, since then, Compose UI has been introduced, announced at Google I/O in 2019, but didn't reach stability until 2021, quite recently. Well, not quite recently, but more recently than 2019. But Compose UI was a way of building a UI structure with a declarative UI framework. It was open source and built in Kotlin, accelerated UI development, and introduced this intuitive idiomatic API for building your view structures. And it was really nice for a lot of people. But an important disclaimer here is that Compose is not the same as Compose UI. There's a good quote from Jake, as there always is. Compose is at its core a general purpose tool for management of tree of nodes of any type. And because a tree of nodes of any type can mean of any type, you can use Compose for just about anything. There's a talk tomorrow from Mohit about the Compose compiler. I recommend checking it out. And in response to this, a little bit later on, Jetpack team continued development of the navigation for Compose. So adopting some preliminary Compose support, things like being able to build a navigation graph with composable Kotlin DSL, composable view models would be scoped to the navigation destination, using destination level scope for remember savable, and automatic backhandling support. And it looked a little bit like this. The nav host composable DSL with creation of screens, simple hierarchy, no real separation of concerns. It's fine for simple apps, but it doesn't really scale all that well. So with this approach, arguments needed to be registered separately declared, with each type information explicitly typed so that this could be inferred when it's actually resolved. This meant that it wasn't actually type safe in the end. And it was a bit cumbersome to navigate to these things because you'd have to build the route yourself, and it would actually represent a URL type structure, and you had to kind of get these values from the saved instance state. So it's very closely tied to the platform implementation. Of course, that was until early this month when type safety was added via Kotlin X serialization. The type was encoded into the root using this reified function here. You can check out more information about this type safety at this blog article here. Like I said, I'll share the slides at the end, so don't worry. So yeah, that was Android navigation on Android. But you know, this talk is about navigation on multi-platform because my other one was rejected. So Kotlin multi-platform, relatively new kid on the block, stable from release 1.9.2. That's not a date format, that's a version number, just to let you know. But this multi-platform thing isn't really a new concept. There have been several concepts prior to this. Many different attempts with multi-platform frameworks, each demonstrating some advantages or disadvantages, some having limited success and some having even less success. Some integrating with the underlying OS and other times not. But each framework could often specify its own language and development build environment. And whilst each of these languages have their own ecosystem of libraries, these are not particularly languages that would be familiar to Android or mobile developers unless life has been particularly cruel to you. So the nice thing about KMP, Kotlin multi-platform, is that it starts small. It doesn't require you sharing everything. You can build components in such a way that makes sense for your application and makes sense for your team. It's a language already familiar to Android developers, which I assume most people in this room are usually familiar with. And it's actually becoming more adopted by backend development as well, with a strong community backing with JetBrains and Google contributing. This is from Kotlin Conf 2023, with stating multi-platform libraries available for Kotlin increasing to 1,200. Obviously, it's more since then. But with the increase of multi-platform for Kotlin, it becomes advantageous not to ignore this anymore and actually start thinking about this from an idiomatic platform perspective. And what's nice as well is that early this year, Google announced Kotlin multi-platform support for the Android X libraries. And that kind of looks a little bit like this as of writing, which was a couple of days ago. This is, by the way, using the correct date format. This is not the 9th of April, but the 4th of September. You might notice that navigation is noticeably absent. But what you might notice as well is that we have a view model. Yay! So for better or for worse, view model is now multi-platform, whether you like it or not. I don't. So whilst there are some components from Android X becoming available for Kotlin multi-platform, we may or may not want to start using them because it's not maybe fully fledged out, it's not really fully fleshed out, it's not fully thought out, and it's just not quite where we need it to be yet. So there are obviously open source alternatives or open source libraries that were there already that we can then think about using. One example of this is Decompose and Ascenti. This kind of focuses on creating this lifecycle awareness API that we'll be familiar with on Android, but making sure that it's available for other platforms as well. Has like an abstraction about this lifecycle and persistence APIs that can happen for iOS as well as JavaScript. And in the absence of multi-platform lifecycle support, this did a really good job of handling this. The core principle of this was using the component contexts. Many functions here should be quite familiar to various platforms, and provided observability and value storage with lifecycle persistence. For navigation, it employed the concept of child stacks, and the screen is created with a given config. It's not inherently Compose. It's sort of a bit clunky in its API, but it does a really good job of what was necessary at the time. So platform hosting capability came in the form of extensions for Decompose. So we had like the extensions for Compose, which was then adding extra stuff on top of that, some extensions for Android for some platform support there, and for Statekeeper for Darwin. But then, introducing Compose multi-platform to this. This is the version of Compose maintained and built by JetBrains, which is originally forked from the Android X repo. So this sort of builds on top of the Kotlin multi-platform ecosystem and became ready for production, or version 1, as of the end of 2021, so that was December. They've since recategorized the terms of stability, referring to platform stability for individual platforms. So Android, by nature of being backed by Jetpack, is usually always stable. Alpha is under active development, and most other platforms are stable. Best effort is probably works, but maybe have some teething issues. But the downside to this, because so much work was necessary in doing so, that the development is a little bit staggered. So the version of Compose multi-platform that you might be using will be referenced to a version of Jetpack Compose, which is a little bit older. So you might be missing out on some nice new features. The documentation can sometimes be not quite out of date, but therefore removed, because the Jetpack navigation documentation, for example, will be referencing the latest version, whereas you need the before the latest version, which is often not maintained. So it's hard to find these things unless you're searching through the Internet Archive. When looking into this, actually, I was really curious about how the JetBrains team achieved this. I was wondering if they did some really clever, fancy repackaging of artifacts and then repackaged it for multi-platform. But they actually just forked the repository underlying that and actually then manually make these changes, which requires a huge amount of work. And I have nothing but the best of respect for these guys for doing it. So under the alpha artifact, navigation is currently actually available, which means that you can do something like this with a nav host with a composable home route and home screen there. You can do this in multi-platform. It's now available if you're using this alpha. Maybe you want to wait a little while until it becomes stable, but it's already available for you to start playing with. You can find out more on the JetBrains Compose site with a detail about the libraries and everything that they're using there. So say if you wanted to kind of start using multi-platform, which now you have no reason not to. If you're migrating from Android X to navigation, you've waited long enough, and Android X library is now available for multi-platform. Congrats. You just have to change the artifact coordinates, do nothing, and profit. Which reminds me of the phrase, which I quite often like to quote, the early bird may have gotten the worm, but the second mouse got the cheese. Just don't think too hard about the first mouse. So that brings in the question about architecture. Considering our architecture goals and how we want to use tooling to achieve them. So reactive architecture might be familiar with the term. It's push, not pull, unidirectional data flow, having a declarative syntax, and being idempotent. It's really hard for me to say, idempotent. And we think about how our code has evolved over the years. So back in the day, we'd have callbacks, and you'd have a bit of code that basically is executed after some operation has been executed. We still have that in a lot of places, and that's okay, but you can quickly end up in callback hell, where you have this deeply nested chain of functions. I didn't show the contrived example here because it would be too much. But then we kind of changed this to sort of an observable chain syntax, where everything is a stream and everything's observable, and it can quickly become unmanageable with Rx operators, with things that are very difficult to learn. And it got to the point where, with all these different Rx operators that are available, it took a real experienced expert to kind of explain what anything even did. And then we had the introduction of coroutines, and this turned this sort of callback style structure into something a bit more imperative. And you get to enjoy the kind of Kotlin structured concurrency as well with it. But because we love reactive programming and flows, we get coroutines and flows again. So this is what we sort of would try and do to achieve. We still have the same sort of reactive syntax with states being created and everything like that. So you might have a loading state, idle state, completed state, whatever state. And coroutines could still achieve that, although now we've just gone back a step. But remembering that Compose is a tree of nodes means we can restructure our architecture using this. And you might have already seen some things like this, where we've then changed these operators to be a readable sequence of declarations. We're actually assigning these to variables rather than having these kind of weird operating chains of reactive modulators. So a bit more readable. This was already explored with Molecule from Cash App. It's a way of building like a state flow of events or a state flow of anything really, using a composable lambda. So you can, inside that lambda, then use composable syntax. You're relying upon the compose runtime there rather than UI, which is really powerful and really nice to use. It looks a bit like this. You can emit a series of events and then consume that as a state flow. If you're using this with Turbine as well, you can have some nice testable flows there. Bill and I did a talk on this 2 years ago, exploring this. I mean, I say Bill and I, but it was mostly Bill. That guy's really clever. So that kind of begs the question, what is the role of architecture in navigation? If we're doing this in such a way that it's reactive, we're deploying compose, we're using multi-platform, what might that look like? And how can we exploit that as an architecture? So taking frameworks from pre-compose and applying them into the compose dynamic works fine, it's okay. But it can seem a little bit unidiomatic. So it's going to be nice to kind of consider architectures which take a compose first approach. Introducing Circuit from the folks at Slack and Zach here. Takes a lot of inspiration from existing frameworks and contributions from the community, things like Cash App Broadway and Workflow, and there's a lot of community involvement, and it's really quite interesting to observe. Driven by Zach here and the rest of the folks at Slack. Designed with Compose in mind, it's powered by the Compose runtime, same principal tenet, separation of presenter and UI, UDF all the way through, so no mutability, Compose first architecture, as a separation of UI and presenter, unidirectional data flow. So starting off with this, it might look like this. Just create a simple screen class. This is how additional individual screens are keyed. The UDP concept revolves around your state. This needs to be parsable so that it can be saved on the backstack on Android. And if you see Zach here, please ask him, can we make it serializable instead? Please. So presenters separated from the UI means they're responsible for the creation of the state, but they're not actually responsible for the rendering of the state or anything to do with that. You're just kind of creating this idempotent object that represents your current state at that given point of time. And then you can create a basic UI to receive and render that provided state, taking a modifier here because we're a good citizen. And then we wire up Circuit with the presenter and the UI, provide the composition locals, and create a backstack with the initial screen. It's not so much there actually. It's fairly straightforward, but it'll look the same most of the time, depending on your implementation as well. This is not using DI, and DI is heavily recommended to being used. There's also kind of code gen artifacts that you can use to help you go a bit faster with this. But interestingly, navigation is handled as part of the state. So we've got this event sync that lives with your state because we always need this sort of event sync to be there. It can feel a little bit uncomfortable at first to kind of package this lambda as part of your state object, but you'll quickly get used to it and find out it's actually quite practical because it can then be evoked from the UI and then handled by the presenter, like so. Here we've got the state and the event sync there. So you have this nice little lambda syntax as part of your state, which handles your events in behavior and just kind of instructs the navigator to then navigate to something. Again, separated from the UI, you've got your presentation logic, nice and clean here. I recommend checking out the video from KotlinConf from Zach and Kieran, where they go into much more depth and explain how it's actually working underneath the hood. Very interesting stuff. There's also some extensions, using Android activities or custom tabs, for example, effects for logins and analytics, not to be confused with UI effects, gesture navigation with support for predictive back, and overlays for bottom sheet navigation. There's also a lot of work been done by Chris Baines on Remember Retained. There's some really clever stuff here about kind of retaining things through composition. So the nice thing about Circuit is that it moves away from lifecycle. The idea of lifecycle on Android or any platform, frankly, has been plagued by misunderstandings, difficulties, and it's just been a real headache to get used to. So being able to move away from lifecycle is quite refreshing in this respect. So you only really care, am I being composed or not? And that's all that's important to you. As soon as the composable is decomposed, everything is cleared off. But sometimes, you might want to save something that would be then kept through that composition. And you don't want to have parsable, for example. So this is Similar to Remember Savable, but Remember Savable needs to be bundled, so it'll only have like primitives or something like that. So this isn't actually parcelized, so it's quite nice like that. So there's some real-life examples on this in the wild. There's the TV app from Chris Baines. This is actually quite a nice app on its own. There's the Catch-Up app from Zach, and Field Spotter, which Zach wrote an article about recently. And there's My Playground, which I feel obliged to tell you about, but it's nothing special, just where I play about with different things. So full disclosure, I've covered Circuit a lot more than other libraries here, and that's kind of because I really enjoy it. This doesn't mean it's going to be perfect for you. There's other libraries that I didn't have time to cover properly. So, definitely go check it out, but it doesn't necessarily mean you must use this thing straight away. There are other options as well. So there's a library called Voyager, which is a little bit more lightweight, a little bit simpler in concept. It only provides you a navigator through a composition local. Keys are again keyed by screen class, which are simply added or removed from the backstack as you see fit or as your requirements require. And nicely, it's that their screen is not parcelable enforced, Zach. It allows the it allows the consumer to enforce this with their own implementation. Just saying. There's other alternatives as well. There's Apex from the Bumble team, which focuses more on gesture navigation. This is quite nice to see as well. You can go check that out. And there's also Precompose, which is similar to Jetpack navigation with a few tweaks. So I tried to make a comparison against of these different libraries of like what their strengths are and what their drawbacks are. But truth be told, it's kind of a subjective metric. A lot of these things are based upon idiomatic code features, how things are nice to use as a developer. There are, of course, some strong points about using Compose and having like a good architecture, but I couldn't tell you that one has particularly good performance, for example. They are idiomatic features, fun to use, an enjoyable developer experience. Which begs the question, why then? What are these features that we're looking for in libraries like this? It's often a pass-off between configuration and ease of use, if you can get it out of the box and start running with it, or if you can configure it and kind of play with your heart's content. There's no need to migrate if you already have a solution that's working for you. If you have that, that's great. Maybe if you're starting a new project, try out these libraries, or if you just want to have some fun. Because ultimately, I think it's important to remember that good code is removable code. Code should be fun to write and even more fun to delete. It should be easy to build new features and easy to delete historical ones. So having a good architecture and having a good navigation paradigm that allows you to do this, to keep things separated and apart, means that you write less code. Less things can go wrong, and you can build in a much more fun way. So if a framework allows you to write less code, that's great. I wrote less code. And that's everything. Thank you. All the slides are available at this URL here. You can check out all the links in the PDF. And yeah, that's all from me. Thanks.